Hey, Algebra 2, welcome back. Here is 13.6. We're going to apply the law of cosines this time, okay? So in 13.5, we did law of sines, and so now this is law of cosines, okay? And so we're going to use law of cosines to solve non-right triangles, just like we did in 13.5 with the law of sines, okay? So why is there two different laws? Like, what is there a law of sines and cosines? Well, it turns out that we can't use the law of sines to solve every single non-right triangle. Okay, we can solve a decent amount of them, but not every single one. Okay, and here are two examples of triangles that we can't solve using the law of sines. Okay, for example, that first triangle. Notice how all of our angles are missing. We don't know any of the three angles of the triangle. Well, if you think about the law of sines, for example, let's say we wanted to solve for this angle right here. We're going to call this one A. That means we would need to do sine of A, capital A, over little a is equal to, we'd have to pick one of the other ones. For example, sine capital C over C. Well, I can't use that one because I don't know angle C. I might know side C. Let's say that this one was angle C and this was side C. I know side C, but I don't know angle C. And so this has two unknowns. Same thing if I replace this with angle B and little b. If I have this as angle B and this as little b, same thing. I still am missing angle B. Okay, so we can't use the law of sines there. And same thing here with this one. If I know two sides and an angle specifically in between those two sides. Okay, if I have an angle and two sides, okay, that angle being in between those two sides, it's the same issue, right? For example, let's say I wanted to solve for this opposite side. Okay, if I call this angle A, I want to solve for side A. That means I choose the other form of the law of sines, the one with the sides on top. So side A divided by sine of angle A. In this case, I know that 97 degrees. Okay, I would have to pick either sine or B over sine B or C over sine C. But again, I wouldn't be able to do that because I don't know any of the other two angles, okay? And then you'll end up coming across the same issue if you tried to solve for one of these angles, okay? And so we can't use law of sines in these cases. And we actually there's a name for these cases. Notice how in this one we are given all three sides. So that's the side case. All right. And then the side angle side case, okay, with the two sides with the angle right in between case. We cannot solve that using the law of sines. Okay, and so we'll have to rely on the law of cosines, and here it is. Okay, there's three different forms for kind of six different possibilities. Okay, using this first form, I'm going to be able to solve for either side A or angle A, side B or angle B, side C or angle C. And so that's kind of what will help you to decide which one of these three to use. What am I solving for? Okay, in this triangle, I'm going to solve for angle B. That means I'm going to need to use the second one. Okay, what if I need to solve for side B? Same thing, also use that second one. Okay, and so this is if you're missing side or angle A, side or angle B, and then side or angle C. Okay, and so a squared equals b squared plus c squared minus 2 times b times c times the cosine of a, so on and so forth. Okay, so let's go ahead and just see how to use these. Okay, let's start with the first example. All right, use the law of cosines to solve each triangle below. Round all answers to the nearest hundredth. Here's our first part of this example. We have side A, side C, and angle B. Two sides with the angle in between. This is definitely going to need us to use the law of cosines, okay? So let's go ahead and whenever we have this case, whenever you have side angle side, solve for the opposite side first. We're going to solve for side B, okay? So that's going to be our first goal, to solve for side B. And so in that case, I'm going to use the second equation because that is solved for b. I would just at the end need to take a square root. Okay, so let's write out the equation first that we're going to use. I have b squared equals a squared plus c squared minus 2 times a times c times the cosine of b. Okay, so now I'm going to substitute everything in. I have b squared, and I'm just going to actually write the equal sign. b squared equals a squared. So 11 squared plus 14 squared minus 2 times a, which is 11, times c, which is 14, and then times the cosine of b, which is 34 degrees. Okay, so there's our setup. Okay, and we can kind of, if you notice, we have everything on the right hand side, we know everything. So I can go ahead and just put this all in one line on my calculator, and that's going to help to avoid with kind of some intermediate rounding that we might accidentally do. Okay, so I'm just going to put that all in decimals. Okay, just to kind of show you on here. Remember, you can always use your own calculator if you have one. So 11 squared plus 14 squared minus 2. And here I'm going to want to use parentheses to make sure that the order of operations is working well. So 2 times 11, close, open, 14, close, open. And then I don't need this second. I actually didn't mean to open that last one. Cosine. So I'm going to grab cosine from my functions. And then actually, before I even put anything in here, I need to go to my wrench, set it to degrees. Make sure if you're using your own calculator that you have set it to degrees. And I put 34 inside of that cosine. Oops, I didn't need that extra one. Okay, and so there is the answer, 61.66. Okay, 61.66 is what we have on the right-hand side of our equation. So I'm going to switch back. Okay, and I'm technically not done, right? Because this is just the right-hand side, and what do I have on the left-hand side still? B squared. Okay, don't forget about the squared, because now we have to square root both sides. So now I have b is equal to the square root of 61.66. And if we do that on our calculators, we end up getting, if I round that, 7.85. I didn't do that in decimals because I think you're capable at this point of doing a square root, right? So we do square root of 61.66, we'll get a really long number, but I rounded it down to 7.85. Okay, so there is our side B. And so now we have found all three sides. We have all three sides. We just need to find the two missing angles now. Okay, so let's go ahead and just start with angle A. Doesn't matter which one you start with, okay, because we're still going to be using the law of cosines. So if I'm starting with angle A, we're going to use this first equation. A squared equals b squared plus c squared minus 2 times b times c times cosine of A. Okay, so let's write down that equation first. Okay, my goal is to solve for A. So little a squared is equal to b squared plus c squared minus 2 times b times c times the cosine of A. Okay, and so let's just fill in all our information, okay? So I do actually know a little a squared. I have 11 squared is equal to, I now know b squared, and we're going to use the rounded, even though we kind of are supposed to try not to use the rounded one. It's going to get really messy if we don't, okay? So there's going to be a little bit of error when we use the law of cosines, and that's going to be okay. Plus c squared, which is 14 squared, minus 2 times 7.85 times 14 cosine of A. Okay, so we don't know A. That's what we're solving for. And so whenever you have to solve for an angle, there's going to be a little bit of work we have to do to get that cosine of A by itself. Okay, so let's do it piece by piece. We're going to do this first right here, this 7.85 squared plus 14 squared. Okay, so figure that out on your calculator, or go ahead and do that in decimals really quick. Okay, I'll do it on my calculator as well. 7.85 squared plus 14 squared. And you can just put it in one line like that. Okay, and we end up getting 257.6225. Okay, and then 11 squared, we know that's 121 on the left-hand side. Next, I want to do this right here. 2 times 7.85 times 14. Oops. And that ends up being minus 219.8 cosine of A. Okay, now there's always the temptation, even when I taught this at NAU, when I taught pre-calc and we did law of cosines, there was always the temptation. Oh, I went a little too far. Always the temptation to go and subtract those. okay? No, we cannot subtract those because notice how this 219.8 is attached to that cosine, okay? This is one thing. This is if I gave you 2 minus 4x, if I gave you that and you told me that that was equal to negative 2x, because 2 minus 4 is negative 2. That is not true. That is not okay, right? So don't ever subtract those two or add them, whatever the case might be. All right, from here, what I want to do is I want to get cosine A by itself. So I want to get this piece alone. So I'm going to subtract this over minus 257.6225. Okay, and I hope you write that down. Normally we don't write the intermediate steps because we're kind of okay with our algebra at this point. But please do write this down so when you look back, you remember, oh, okay, I didn't combine these two. I subtracted this to the left, okay? So we'll do 121 minus 257.6225. And we get negative 136.6225 is equal to negative 219.8 cosine of A. Okay, now I want to get this cosine of A alone. So now here I can divide both sides by 219.8, make that negative actually. Okay, negative 219.8. All right, and so then when I divide those two, so divided by negative 219.8, I end up getting cosine of A is equal to positive 0.621576. We'll use, they give us a lot, but since we're in the middle of our work, let's use at least 6 of those decimal places, right? And so here we know how to solve for A because we've been doing that in 13.4. To get rid of that cosine, I undo it by doing cosine inverse. Okay, cosine inverse of both sides. Cosine inverse. So I get that A is going to be approximately, I take the cosine inverse, you can do this in your calculator or in decimals, 0.621576. We get 51.57 degrees. 57 degrees. Okay, so there's our A. And so now if we look back at our progress, we have angle A, side B, and now we're just missing angle C. And here we don't have to do anything fancy. We know 2 of our angles. So we can subtract from 180 to find that C. So let's do that. Okay, so C is going to be 180 degrees. Oops, 180 degrees minus this 51.57 degrees minus the 34 degrees. Okay, so what do we get when we do that? 180 minus 51.57 minus 34. We get 94.43 degrees. Okay, and just like every time we solve a triangle, let's go ahead and write all our answers in one place. So I got side B was 7.85, angle A was 51.57 degrees, and then angle C was 94.43 degrees. And there is our answer. Okay, so far so good. That was our first triangle. Let's do one last one to get the hang of it. Okay, here is a side, side, side case. Okay, we are given all 3 sides. And so we're going to do the same thing. We're going to use the law of cosines. And notice how in the first one we had to use it twice. In this case, it'll have to be the same thing. We'll have to use it twice, okay? Just like with law of sines, we also in the past had to use law of sines twice whenever we were solving the triangles using law of sines, okay? So here, again, doesn't matter what we choose first to solve for. Let's go ahead and just, we're looking for angle. First thing we should do is just figure out what we're looking for. So angle A, B, and C. Okay, so let's just start with angle A. And since I'm looking for angle A, we're going to use the equation that has the a squared and the cosine A. Okay, so I'll write that equation down first. A squared equals b squared plus c squared minus 2bc times the cosine of A. Okay, so now I fill it all in. I have 12 squared is equal to 27 squared plus 20 squared minus 2 times 27 times 20 times the cosine of A. Okay, so it's kind of like the second one we did. let's go ahead and figure this and this out first, okay? So 27 squared plus 20 squared is 1,129. Over here we have 144 on the left, so then 1,129 minus 2 times 27 times 20 is 1080 cosine of A. Okay, again, we can't subtract these, so instead of subtracting these, make sure you write this down. We're going to subtract that 1,129 to both sides. Okay, so 144 minus 1,129 is negative 985 is equal to negative 1080 cosine of A. Okay, I can divide over the negative 1080. Okay, so divided by negative 1080. I end up getting that cosine of A is 0.912037. 2037. Okay, just like last time, let's use at least 6 of those decimal places. And here I can go ahead and cosine inverse both sides to get rid of that cosine on the left and get A all by itself. Sorry, I kind of squished it up there. So that means that A, angle A, is the cosine inverse of 0.912037. And so we end up getting A is 24.21 degrees. Okay, so there's our first angle. Okay, all we need to do is do the law of cosines one more time to get the second angle, and then we can just subtract them from 180 to find the last angle, okay? So let's just now look for B, angle B. Okay, and so we need to write down that formula. That's the formula that has the B squared. So B squared is equal to A squared plus C squared minus 2AC cosine of capital B. Okay, and if you haven't been believing me this past few times, just go back and look at your formulas, right? You should already have them written down. You should be able to kind of look up at them, whereas I have to kind of scroll all the way back up. Okay, so there we go. Let's plug everything in. So B squared is 27 squared is equal to 12 squared plus 20 squared minus 2 times 12 times 20 times the cosine of B. Okay, so now let's go ahead and clean everything up. 12 squared plus 20 squared, that's actually not bad, right? Because 12 squared is 144, 20 squared is 400, so that's going to be 544. I don't know what 27 squared is, so let's get that. That is actually 729. Okay, and then 2 times 12 times 20. Well, 2 times 12 is 24. 24 times 20, that's going to be 480. And I'm going to put that in my calculator just to make sure, because now I'm doubting myself. Yep, 480. So minus 480 cosine of B. Okay, again, I'm going to say it one last time. Don't subtract these. Okay, instead, I'm going to subtract the 544 to both sides. Okay, so 729 minus 544, that's 185 is equal to negative 480 cosine of B. Okay, I can divide over the negative 480. And so we end up getting cosine of B is equal to 185 divided by negative 480. We get negative 0.385417. Okay, and just like we have done, we take the cosine inverse of both sides. Okay, so B ends up being cosine inverse of negative. Don't forget the negative, right? It's okay to put a negative inside our cosine inverse. Negative 0.385417. Okay, and so that's going to get us an angle of 112.67 degrees. Cool. So now we have one last step to do. Our angle C is going to be 180 degrees minus 24.21 degrees minus 112.67 degrees Okay, so let's figure that. We end up getting that C is 43.12 degrees. Okay, and so now we go ahead and write our answers down in one place. A is 24.21 degrees, B is 112.67 degrees, and then C is 43.12 degrees. And there is our answer. Cool. So there's law of cosines, okay? In each problem, we've had to do it twice, okay? And so you might have to do that sometimes. You're either going to find two angles and then subtract from 180 to get that last third angle, or you might have to find a side and then an angle and then subtract again from 180 to get that last missing angle, okay? Those are kind of your two possibilities, all right? And so that's law of cosines. We had law of sines in the previous section. Hopefully that sounds good. Let me know, as always, if you have any questions, okay? See you in the next one. Bye-bye.